screen, copy it, and record, and we're gonna solve and do more.
Yeah, record you. Yes.
And solve more equations, more trig equations for beta or x. So more of 6.2. If you have something such as tan squared x plus tangent x minus 2 equals 0. And over the interval, what if I told you a different interval? Actually, I'm not going to tell you a different interval yet, but I could. I'm going to very soon. Yes, sir.
I need to get something from the store soon.
Come back. You ready?
Yes.
Now, when you see this type of equation, what I want you to think about, okay? So if I'm doing my side bubble, thought bubble over here, I'm thinking, do I know x squared plus x minus 2? So if where you see x, it really is tangent x. Okay? So is that x squared plus x minus 2? Can you factor x squared plus x minus 2? I just need you to know that everybody, yes, I know that you can factor. Can everyone factor? This is probably one of the easiest factoring problems. Okay? But I need to know that you can factor. Okay? We don't make it very far. So if you can factor this, x times x is x squared. What are factors of 2? That subtract to get 1.
2 and
2
1.
and 1 is the only possible numbers. Now, when they subtract, we need a positive 1. So which one needs to be negative? Which one needs to be positive? Negative 1, positive 2 equals 0. And then how do we solve for x?
Set it equal to 0.
You set each piece equal to 0. So you have x plus 2 equals 0. So x equals negative 2. X minus 1 equals 0. So x equals 1. Okay? So now how do we translate this algebra stuff we already know back over to tangent? What times itself? What times what gives me tan squared? Tangent x times tangent x gives me tangent squared. What times what gives me 2?
2.
2 and the 1. 1 has to be positive. 1 has to be negative. It's the same exact thing. And then we set it equal to 0. Okay? Now, we're simply doing what? Setting each. Well, I'm going to not draw a triangle yet. I'm going to set each piece equals 0 and tangent x minus 1 equals 0. Okay, so you're solving tan x equals to 2 different equations. Okay, I like this one better. Tan x equals 1. That one's a lot easier. When does tangent x equal 1? Between 0 and 360 degrees. 90? Oh, it's 45. So our triangle that Emily wanted us to draw is 45, 45, 90. So x equals 45 degrees. Is that our only answer just in this piece? No. Where is tangent positive?
2 on 1 and 3.
So I'm going over here. It's in quadrant 1 and quadrant 3. So we've found a reference angle, 45. What was it, 225? Okay, so those are for that piece. Change colors. Didn't even realize. Okay. What about the other piece? When does tangent x equal equal -2. I don't really have a triangle set for that. Can I simply just plug it in my calculator?
Yes.
You get this wonky number though.
Okay, what? First question is, what mode are you in?
Degree.
I should be, yeah, I'm in degree.
Okay, so inverse tan of -2.
It's very weird.
Yep, wonky.
What do you consider wonky then?
Well, I mean,
When you said that, I assumed it was gonna be like a decimal number, like 0.25 or something crazy.
I mean, it's like, it does have decimals.
It does.
But there's a lot.
-63 degrees. That's what I got.
Yes.
So technically, no, that was not round up. -63 degrees is kind of where we're going. Is that in our range? Is that in our interval?
Oh,
-63 degrees is not in our interval. But when we plugged it in our calculator, we got this -63.43 blah 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 degrees. Now, on my triangle, where is that? Not triangle. On my coordinate plane.
Quadrant 4.
-63 point whatever degrees. Okay? So what do we need to do? We need to find a coterminal angle. So how can we find a coterminal angle with negative?
360 minus 3 minus 63.
You can
No,
simply say
360 plus -60.
yes. Either way, I'm just plugging in my calculator plus 360. So I got what? 296.56 degrees.
-6.6. Can I round it to 97?
Sure.
How'd you get? What'd you get?
296 degrees.
How's it?
Oh, technically 7, but
Yeah, that's what I was.
well, I got 296.565. Blah 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 blah.
How did you get the 63.4?
Plugged it in my calculator. Inverse tan -2.
Wait,
It
what
asks-
much should my calculator be? Radians?
Degree.
If I'm asking for degrees, it needs to be in degrees.
Yeah, it's been in radians.
It has been. We have been changing it back and forth. At what time? At sometimes. If I were to put the same problem up there, but put 0 to 2 pi, I would expect you to be in radian mode. Okay, so now it's your responsibility to get to know when do I need to be in radian, when should I be 296.6 degrees. Is that the only other answer?
No.
No, quadrant 2.
Should there be?
I think your calculator don't work.
How can my calculator not like you?
I don't know.
How? Okay, wait. Back to this. Tangent is negative. Where is tangent? -2. So we are in quadrant. But we just did the one. This one down here was 296.5 degrees. 0.6 to make it actually be there. But it is also negative in quadrant 2. Yes, ma'am.
But tangent.
These are two separate problems. This one, tangent was positive. Tangent x equaled 1. We were positive. We were in the first and third.
Oh, but it's not.
Tan x over here is -2.
So you're only looking at
So I'm now only looking in the second quadrant and the fourth quadrant. The first one it gave me, this negative, was in the fourth quadrant. So we found its coterminal angle. What is the other angle that's in quadrant 2? How are we going to find that?
I use 90 plus.
You can do the reference angle of the 63.4. Okay. Is there another way? You can add 180 or subtract 180 from that 296. Well, if I add it, it's going to be more than 360. It will have to be a coterminal angle with this one. Okay? So I'm going to subtract it. You will get the same thing. You actually plug in the numbers 1 and the 8 and a 0. So this should be from here to here. I got 116.6 degrees.
160.
Does it matter how many decimals we go?
I got 150.
153. So did you do 180 minus 63.4? Should be 116.6.
I used 90
We're not going 90 plus 64. The 64 is not right here. It's on this side.
Okay. Your calculator really don't work.
It's not my
Look
calculator.
at me, look at this. I cannot.
Okay, no. This is not my calculator.
Oh,
This is the
somebody.
calculator that was found that on the back. If you know of Michael Bradfield,
Who's that?
I don't know. I've never heard of him. But this calculator is awful.
It's Michael's.
It's Michael. Somebody found it, somebody left it, somebody used it, and then it accidentally got left on
Your room.
my table and then on my room and it got put over there. It is awful. I tried to use it yesterday. So, you need the one that is mine.
He likes me so much. 116.
116.6. So you have 4 answers. They didn't all come out nice like they have been. Okay? We had 2 that were kind of not. I mean, these are kind of not.
Around it to 17.
Wait, I
Whatever.
have a doubt question. How do you know that negative 63 degrees is in 1.4?
Oh yeah.
Because from the very beginning, when we talked about negative, we're always starting here. Okay? Negative angles go down.
Okay.
It starts on and you just go 63 degrees.
Okay.
Any other questions? All right, can we factor another one? Could you do one? Could you do it in radians? What if I gave the same problem to you in radians? That's what they did in the book, and I was 9. The only difference is these will be in terms of pi, and these will be just radian decimals. It turns out to be negative 1.107. And they add the pi to it. Alright? Let's do another one. 3 sine squared. X minus sine x minus 2 equals 0. And this time I am going to give you in radians.
Oh gosh, I don't remember how to factor some other coefficients.
I've learned algebra 1. There's an AC method. I've actually learned it pretty bless you. But I really don't like it. The more I've done it, the more I really don't like it. This one is super easy because 3 and 2 are prime numbers. Okay? So if you have 3x squared minus x minus 2, what I do, I list factors. What are the only factors of 3 and the only factors of 2?
3, 1, 2, 2, 1.
So make a combination where they subtract to get negative 1. 3 minus 2. Is that going to give you negative 1?
Oh, negative 1, 2 minus
2 minus 3. So you need a 2 minus 3. How did you get 2? 2 times 1. How did you get 3? 3 times 1. So how am I going to write that? 3, I'm always putting it first. 3 sine x times what gives me 3 sine squared? This is your 3 times 1.
Oh, okay, I see. So
Now the 2, the question is where do I put the 2? Do I put the 2 over here? Or do I put it right here? If I want it to be times a 1. I don't want them, if I put them here, I'm going to be doing 3 times 2. We never multiply together things that are inside the same parentheses. So I'm going to put the 2 inside that. My method is a guess and check. It's very quick to me. I can do it in like 5 seconds because I've done it a lot. Okay? The AC method takes forever. It's a methodical thing. It works every time. And blah, blah, blah. I don't like it at all. It's awful. They're factoring with a 2x and a 15 and subtracting to get 13. And you need to do that. You need to be with me to know how to do that because I'm going to make you do it. Next year. This year, hopefully. I always say I don't get some more stuff, but it never happens. All right, so I need my 3 to be negative and my 2 to be positive. So the 2 goes there, 3 goes there, well, negative. And then I'm going to check. The only thing I care about is my middle term. Because I'm not writing anything that 3 sine x times sine x is sine squared. 2 times negative 1 is negative 2. The inside and the outside gives me a negative 3 sine x and a positive 2 sine x and a positive 2 sine x. Does that give me a negative sine x in the middle? What?
Yes.
Oh yeah.
Negative 3 plus 2 gives me a negative 1.
Oh yes, it does.
Yeah.
Negative sign X.
Huh?
Negative 3 plus.
Negative 3
Oh,
sine
I
x.
thought you were trying with something else. Might be.
This is my middle term. That's the only one I really am going to check, and I usually check it in my head. But I start making kids write it down.
We need to answer it.
Yeah, so here we go. Answers in radians. I'm erasing my check. So here we go. So we need to still equal 0. So we have 3 sine x plus 2 equals 0, and sine x minus 1 equals 0. I like to go with what's easy first. So this one over here, sine x equals 1. Where in the world does sine equal 1? And I'm looking on my graph, or you're plugging it into your calculator.
90.
90 degrees. What mode are we in?
Degree.
No, right.
Radian. That's what I'm doing.
Yeah, this right here says I need to be in radian mode. So
I
x
really have
equals
it in radians in my paper. I'm just silly.
pi over 2. Is that the only time sine will be 1 within a 2 pi period? Yes, it will. Okay, so we're done with that equation. Move on to the other one. So 3 sine x equals negative 2. Sine x equals negative 2 thirds. Is there a triangle where the opposite is 2 and the hypotenuse is 3? Not that we know offhand. So guess what I'm doing? Making sure I'm in radian mode. And I'm hitting inverse sine. Sine negative 1 of negative 2 thirds. And I'm also thinking, where is sine negative? In quadrants 3 and quadrant 4. So did you get, what did you get? 7, 2, 9, 7, etc., etc., etc. I might even say 0.73. We all got that? All right. Is that acceptable? No. Because I need it to be between 0 and 2 pi, so it has to be positive. Okay? Should I just add 2 pi? That's definitely going to get me one of my answers. So I'm scrolling down a little bit. I have to see a visual where I'm supposed to be at. I need to be in quadrant 3 and quadrant 4, because that is where sine is negative. This answer right here gave me a negative 0.73 radians. So if I were to add 2 pi to that, I would be at the exact same spot. So can I add, what is 2 pi again? 6.28, yada, 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 in radians. Because 1 pi is 3.14, yada, yada, yada. So I'm going to add 6.28, whatever 2 pi is, so plus, and I'm actually going to enter 2, and I'm going to enter a pi. So I get 5.5, 5. X equals. Now, big question is, how do I find the other piece? How am I going to find? Okay, I hadn't thought about doing that. He said pi over 2, not 2 pi. So it's 90 degrees. Is it 90 degrees from here to here? It looks like it. Because I draw everything beautiful to scale. Okay. You can't go with how I draw things. The big question is this right here negative 0.73, not negative, just a reference angle of 0.73. Because that's what we're looking at. We're looking at this reference angle and this reference angle being the 0.73. They don't. I'm going to go to pi plus 0.73 is generally what I'm going to do. Because right here is pi, and then I'm going to add 0.73 to it. That's what I was thinking. I don't know if it will work both ways. I'm going to add a positive.
And you're trying to get 5.55.
No, we've already gotten that. That's one of our answers. Okay? That was this first line.
It's close, but it's a little off.
That was this line right here, Justin.
Yeah.
That was the same spot.
You can't just subtract the pi over 2.
Okay, I didn't think it was automatically just 90 degrees from it.
Well, no, because the only thing that, like, point that you could do that would be the 45.
45.
Because that makes the 90 degree angle.
Okay. So for our other one, we added pi plus 0.73 to equal 3.87. We'll just leave it at that. Do you visually see?
No.
Okay. I'm going to go to another page. I'm going to show we knew that sine x had to equal negative 2/3. Okay? So first two questions. Where is sine negative? Okay? So in quadrant 3 and quadrant 4.
Oh, yeah.
Okay? So when you plug in your calculator, x equals inverse sine x. Inverse sine, not x. Negative 2/3. Okay, plug that in. We get an answer. X equals negative 0.73. Okay? That's an angle. It's negative something degrees. Okay?
Because it's negative, it's just a reference angle.
Yes, because we don't want an angle that's negative because we need 0 to 2 pi. So that was this. This was a negative 0.73. Okay? We don't want negatives. So we're adding 360 degrees or 2 pi to get the first one. Were you okay with the first one?
Yes, ma'am.
Okay? Just like all the other ones we've done, that again is our reference angle. Okay? We could have said 2 pi plus 0.73. Okay? So to come over here, this distance is also a 0.73 reference angle. Okay? So then what is the distance if I want to go from here to here is pi plus 0.73 more. Okay? So that's going to be an angle that's going to be going this way. So I'm going to add pi, which was my 180 degrees. Got me me to that line, plus this reference angle more. Tangent is actually the easier one, because it's always straight across from each other, and you just add 180 to it. Sine and cosine are a little bit more difficult. Cosine's generally not. Because they're in quadrants that are, well, this is in quadrants right beside, but this one is easier to do right beside each other that way. Okay? So your x's, your answer for that problem, x is pi over 2, x is 3.87, and x is 5.55. There were only 3 answers.
And why did the first one only have what?
Because between 0 and 2 pi, sine is only 1 once. In your curve, it hits 1 and it hits negative 1. But we didn't want negative 1.
So by the time we get back up to 1, it's out of our range.
Yes. Once it gets back to 1 again, it's out of our range. Would you like to do another? Yeah. Let's try another factoring. Oh, that one doesn't want a factor. Could we do 10 squared x plus 3? Oh, that one's too easy, but this one's easy. Alright, can you factor? What are you going to do first? Do what?
All
Subtract 4
give
from
us 0.
You can subtract 4 from both sides. You can. You're adding a step to it. Is there a middle term? This one's not near as hard as the last one. Oh, wait, we need to be between. Let's do 0 and 2 pi again. Chris, do you have gum again? Come on, spit it out.
You want this in radians or
0 to 2 pi, so we want radians. One of the harder things about this is you get an answer and you think you're done. Did you ask yourself, could there be more than one answer? Did anybody subtract 3 from both sides? Even if you brought the 4 over, you eventually had to add the 1 back, right? Yes, if you subtracted 4, you got 10 squared minus 1 equals 0. Did you add 1 to both sides?
So, but like the end would be minus squared x equals 0.
Or maybe you saw, if you did it that way, if you subtracted, did you see the difference of squares? 10 squared minus 1, 10 squared plus 1, or 10 squared minus 1 is the difference of squares. Again, just another way to do it.
Wait,
But I will.
could you remind me how we do the differences?
Okay, can I do this one? And I will talk about that one in just a second. So tan squared x equals 1. The big thing you have to remember with this one, when you take the square root, does tan x simply just equal 1? When you take the square root of something. So you're telling me
Oh,
what's
I
the
didn't
square
do
root
this
of
one.
9?
I didn't do this.
3.
Okay, so nothing else times itself
Negative
gives you 9.
3.
It can also have a negative 3. So when you take the square root of 1, it should be plus
Or minus.
or minus. Because negative 1 times negative 1 also gives me a positive 1. Okay? So you need to think about that. Where is tangent positive 1 and negative 1? Okay? If you went tan squared x minus 1 equals 0 and thought, what is the difference of squares? How does the difference of squares factor every time?
Oh, so it's just
And then you set each one equal to 0 and you're given two different solutions of tan x equals 1 and tan x equals negative 1.
So it's the same.
It will be the same thing, yes. This one will give it to you automatically. This one you have to remember positive and negative. So you're still left with tan x plus 1 equals 0. Minus 1 equals 0. Okay? So now, you're thinking all around your plate from 0 to 2 pi, when is tangent positive 1 or negative 1? So which quadrants are you in?
1.
All 4 of them. But in quadrant 1 and quadrant 3, it's positive, and then in quadrant 2 and quadrant 4, it's negative. So we actually need an answer in all 4 quadrants. You're pulling your plate out, and you're giving me all 4 tangent quadrants in
So we just find
What?
cosine angle 45.
radian mode. So x equals, yes, all 4 places. Oh, are we out already? 6 is out. I was going to make you do the quadratic formula. You'll do it tomorrow. What numbers? Where is tangent equal to 1? Tangent of what angle equals 1?
Oh,
So I'm looking at my reference angle is 45, 45, 90. So that is positive in quadrant 1 and quadrant 3. Okay? But then over here, when we subtract it, we got tan x equals negative 1. So where is tangent x negative 1? In quadrant 2 and quadrant 4. Same reference angle. Yes, ma'am.
and they're all positive.
I did not write